In this video, we are going to solve some sample examination questions on Introduction to Probability. And the questions are arranged or categorized into two parts, which we have 1 to 3 as first part, and the second part we'll look at it before this video ends. So with the first part, the questions are under the early stage of Introduction to Probability, which falls under set theory, laws and the probability, properties and definitions of probability. So most of the times in an examination relating to probability, we are asked about some definitions of probability and also some set theory of probability. So with this first set of questions, you will be able to understand and how you can answer them in examination. So these are some examination questions that I've added, and you will. So with the first question, they are asking us an event is called dash if there's a certainty in its occurrence. So one may ask, what would that be? So would that be, what would that event be? This is some explanations that, or some definitions in probability, and there are types of events that happened in probability. So with this, the answer is impossible event. Impossible event. And with number 2, this an event is called dash of two events X and Y if it occurs whenever X occurs but F does not. And with this, I guess you know this, right? This is the difference. So in this case, if you don't understand the definitions under probability, you will find yourself wanting. So in that case, I have made an arrangement that I'm going to define all definitions under probability. That's why I include these two questions. And these two questions are from examination questions, right? And they are also examinable. So the first definition we're going to take is, what is an event? So most of the times, what is an event? So please kindly take your pen and your book to write these definitions down, because it's very important, and whenever it occurs in the exams, you'll be able to answer them. So the first one is the event. So event, we are going to explain event. So when we talk about event is the outcome of a random experiment, and we could also call it a subset of a sample space. I hope you had that. Second definition we are going to take here is subset. When we talk about subset, an event A is said to be a subset of an event B if whenever A occurs, B also occurs. That is the definition for subset. Now let's move on to certain event. What is certain event? Certain event. Certain event. And when we talk about certain event, an event is called certain if its occurrence is inevitable. That is, the sample space is an event which falls under certain event. So whatever you do, it will happen. That's a certain event. Then we go to impossible event. That's what I explained. An event is called impossible if there is certainty in its non-occurrence. Therefore, the empty set, which is represented by this, which is, so when we talk about the empty set, that's sample space complement, is an impossible event. Let's move on to intersection. When we talk about intersection, an event is called the intersection of two events A and B if it occurs only when A and B occurs simultaneously. And with that, as you know, is denoted by A intersection B. Let's move on to union. When we talk about union, an event is called the union of two events A and B if it occurs when at least one of them occurs, and which union is denoted by A union B. Let's move on to complement. With complement, an event is called complement of an event A if it only occurs when A does not occur. So with the complement, we have a symbol which we have A bar or A and a little superscript C. Let's move on to difference. An event is called difference of two events A and B if it occurs whenever A occurs but B does not, and it's usually represented by A minus B. So these are some definitions. We could also talk about mutually exclusive and mutually exhaustive. So the difference between mutually exclusive and mutually exhaustive is that with mutually exclusive, if the joint occurrence of two events A and B is impossible, we say that A and B are mutually what? Exclusive. And with mutually exhaustive, two or more events are said to be exhaustive if their union equals summation of the sample space. Let's look at mutually exhaustive. Two or more events are said to be exhaustive if their union equals the sample space. So these are some definitions that I want you to take down and note that in examination you might see all these explanations and then you are supposed to provide the correct answer, being subjective or objective. Now let's move on to question number 3. With question number 3, it's going to make us understand set notation, which is set theory, right? Yes. So with question number 3, we are going to apply set notation, in this case from set theory. And let's read the question. Suppose we have 3 circuit boards A, B, and C. What is the mathematical expression or the set notation for the following? So we learning the set notation too is very important, and it will make us solve some of the questions very easily. Yes. So with question number 1, we are supposed to find only A occurs. And with only A occurs, when you are expressing it in set notation form, we have it A intersection bracket open B union C or complement. And you can express this using the distributive law. So if you don't want this, you can also write that A intersection B complement union A intersection C complement. So you can also express it as this. With question number 2, they want us number 3B. They said both A and B occurs. So we should write both A and B occurs. With both A and B occurs, we have A intersection B intersection C complement, but C is not part. Let's look at C, which is C in this case. We take out question number 3C. At least 2 events occurs. When they ask us to write at least 2 events occurs, in that case, you using the mathematical notation or the set notation, what you're supposed to do is that you're going to have it to be at least 2 events occurring, means that it could be 2 events or more. And in this case, we have 3, so it's 2 or more, right? So we are going to express that as A intersection B intersection C complement union A intersection B intersection C B complement union A intersection B intersection C A complement. Then we have this union A intersection B intersection C. Because they are looking at least 2 events, it means that 2 or more events occurs. And with number D, they ask us to do at least 1 event occur. So with D, at least 1 event occurs, that is two or more. So in that case, we could write that A union B union C. So we are looking at all the events occurring, right? That's at least one event. With E, they're asking us to one and only one event occurs. So we are looking at one and only one event occurs. In that case, we could have some possible solution, which would be A intersection bracket open B union C complement. Then we have union A union C, A union B complement intersection with C union B intersection with A union C or complement. Because with this question, they ask us to one and only event. Okay, so have this, have this, have this. These are the possible set notation that we could use, and they are all union, and we get that answer. Let's look at F. With F, I know with F, you could, all of you could do it, right? All three events occur. With all three events occur, it will be A intersection B intersection C. Now let's look at J. Not more than two events. When they say not more than, it means that it is two or less. That's less than two. At least two. More than two. Two or more. Are you getting it? Not more than two, it means that it's two less. Two less, right? So with that, when you are writing that, you're going to have that our G will be bracket open intersection B intersection C or complement. So you could have expressed that A complement intersection B complement intersection C complement. And with H, exactly two events occurs. With exactly two events occurring, we could do it like H. We have it to be exactly two events. We are finding only two events. It could be simple for us. A intersection B complement intersection C, because these are two events occurring, and then union A intersection B intersection C. In that case, A complement, then union. Have the last one, A intersection B intersection C. In that case, C complement. And question in which you're going to understand the classical definition of probability. A survey of a group viewing habits over the last year revealed the following information: 28% watched gymnastic, 29% watched baseball, 19% watched soccer, 14% watched gymnastic and baseball, 12% watched baseball and soccer, 10% watched gymnastic, soccer, and 8% watch all the three sports. So in this question, we are asked to calculate the percentage of the group that watch none of the three sports. So for us to find none of the three sports, we need to establish something here. Now, from laws of probability, we could know that, but first let's J represent the number of that's the number of people who watched the gymnastic as follows respectively. So G, B, S all representing their following information. So we could write that from here we are finding none of the three sports. So you finding none of the three sports, we have a formula which establishes that the probability of an event occurring is equal to 1 minus the probability of that event not occurring, or the probability of that event not occurring is equal to 1 minus the probability of that event occurring. So in that case, we could establish from here that we could have that probability of G union B union S complement is equal to 1 minus the probability of what? G union B union C. So the G union B union S, this S is, sorry, S here. The S represent the sports, B represent the baseball, G represents the what? The gymnastics. So in that case, from De Morgan's law, we can expand this as 1 minus expanding the probability of G union B union C, we could expand that probability of J plus the probability of B plus the probability of S minus the probability of J intersection with B minus the probability of J intersection with S minus the probability of B intersection with S, then plus the probability of J intersection with B intersection with S. So this is from De Morgan's law. And with De Morgan's law, you also take note of that we could expand this as this. So in that case, we're going to have 1 minus the whole thing. And when we do substitution here, we could know that probability be equal to 1 minus, let's do this bracket open. Probability of the percentage of that is gymnastic is 0.8, that is 28%. Plus we have baseball is 0.9, 0.29. Plus we have our soccer to be 0.199. Then we go to minus probability of J intersection with B is 0.14. Then we have minus probability of J intersection with S is what? 0.1, that is 10%. Then we have the probability of B intersection with S is 0.12 and 0.12. Then plus their intersection, 3 intersection will be what? We have 8% watching that. We have 0.08. So we close the bracket. So in that case, we find the probability, that's for probability of the 3 not occurring. That will be 1 minus the whole thing, which is going to give you 1 minus 0.48, which will give you 0.52. In this case, we have it at percentage as 52%. So we find the probability or the percentage of group that watched none of the 3 sports during the last year. We could establish that probability of an event occurring is 1 minus the probability of that event not occurring. We could establish that using here, that is the probability of an event not occurring is equal to 1 minus the probability of that event occurring. So you not watching is equal to 1 minus those who watched. And we could express this using De Morgan's law as this, and then we do substitution, and at the end you're going to have 0.52, which is 52%. This is very important. The reason why I chose this question is that it makes you understand the De Morgan's law, and with introduction to probability questions, most of the examination questions involve this De Morgan's law and also this identity. Let's move on to the last question, which also make you understand the classical definition of probability. Now in this case, we are going to analyze that a pilot plant produce metallurgical badges, which is summarized. So we should find the estimated probability: A, low in impurity, 2, high strength, 3, high impurity and high strength, and for both high impurity and low strength. So when you get a question in this table form and they ask you to find the probability, or in this case we have that low strength with low impurity, under low strength we have 2, high strength you have 27, and high impurity under low strength you have 12, high strength you have 4. So in that case, with question number 1, it's asking us to find the probability of low in impurity. And with low in impurity, as established, you just go first, we need to find the total, that is the sample space. Total the total, in which case we have 2 plus 27 plus 12 plus 4. The total is 45, which represents the sample space. And question number 1 is asking us to find the probability in low impurity. So low impurity is here. So what you do now is that you're just going to sum this low impurity, is this one. So we're going to have 2 plus 27 all over 4. In that case, low impurity will give us 0.64. I find the probability of low impurity, that will be equal to 2 plus 27 all over the total. And with number 2, high strength. We're supposed to find high strength. With high strength 2, this is high strength, right? So for high strength, you're going to sum the high strength, which will be probability of high strength will be equal to, you sum this, that will be 27 plus 4 all over the total, which is 45. In that case, we're going to get a probability to be 0.689. Let's look at the third one. For the third one, we are finding high impurity and high strength. So for high impurity and high strength, this is high impurity. For high impurity, for both high impurity, so high impurity is here, and low strength, and this low strength. So in that case, what you're going to do is that you're going to select, I getting it. So high impurity, both high impurity, this is high impurity and low strength is here. This falls under high impurity and low strength. This is it. So in that case, when finding the probability, you're going to have the probability to be 12 over 45, which will give you 0.267. You could also find the last probability, which will give you high impurity and high strength. Let's do that. Oh, okay. So with this high impurity and high strength, so this is question number 4. I did question number 4, which is both high impurity and low strength is this. High impurity and low strength is this. So let's do number 3. With number 3, they're asking us to find high impurity and high strength. So high impurity and high strength is here, matches to this. That's very simple as that. So the probability will be 4 over 45, giving you 0.08